My name is Muayyad. I'm currently the host of the Greater Seattle.NET group. Thank you for coming. Today we are hosting Tamir Dresher. I'm sure that he is gonna talk about himself a bit when it's his turn. We usually do it like each time we meet. I will just ask a few questions like for who comes, just because we are curious. Who here is an FT at Microsoft? Cool. So most of you. Who works in Azure Core? Okay, nice. Okay. Who works in E&E?
One. Security, Microsoft. MSec.
One sec?
MSec.
MSec? Okay, nice. Nice to meet you. So without further ado,
thank you. Can you hear me? Okay, great, thanks. So thank you all for coming. I'm really excited to be here and talk. And I wonder how many of you have seen this type of like profession, right? When I was a kid and went to all kind of festivals, carnivals, I used to see, and I was really excited seeing this one-man orchestra. And like in the previous year where AI really came into my life, over time, I kind of got this feeling that I'm becoming something like that, like a one-man orchestra. Like I'm suddenly doing so many things. I'm like running my team of agents, and I'm like one is developing, one is testing, one is thinking, and so I kind of remember that. And while writing this presentation, I kind of thought, well, we are all kind of becoming something like that, right? We're a single person, but becoming like a fleet of developers and engineers. And really, what I want to do in this talk is kind of go to this journey, the evolution of AI that I had during the last year or so, and kind of how it evolved into the process that I'm now doing, which allow me really to run like a scalable team of those AI agents working for me, and like the tips and the tricks and the things that I developed over time. So my name is Tamir Dresher. I'm a principal engineer in the Microsoft security. I belong to a group that developed the Kubernetes platform that hosts and run most of the Microsoft security products. And beside that, I'm also, in the past 13 years, I'm also teaching software engineering at the Rupin Academic Center in Israel, having this, access to all those very young minds that I'm helping to shape to work in the real modern world. So prior to the work I'm doing in Microsoft, I've been an architect, chief architect in several companies. I've been a Microsoft MVP. I wrote a few books on .NET. And currently I'm also leading the .NET Bond. It's like the .NET community in the Israeli site for Microsoft. And also part of the community for the .NET inside Israel itself. And so before we start, I like to kind of talk about the tool that I'm using, like my favorite tool for AI agentic development. And everybody got like the reference, right? The picture. I'm not sure, there are young people now, and not everybody knows the movie. So each time I hear agent, like this is the picture that comes into my mind from the metrics, and I kind of imagine Agent Smith just working for me. So you will see a lot of Agent Smiths in this deck. And so there are plenty of tools running, AI coding today. And like from the past experience of this year, I came to notice RuCode. And I find this tool really, really productive for me. And I just wonder, how many of you know RuCode? Okay, how many are using like Copilot, for example, or Claude? Yeah, so there are a bunch of tools out there. And the thing that happened while I wrote this presentation, that every kind of trick that I had suddenly became available as part of the tool itself. So it's kind of a race that while I'm writing the presentation, I kind of keep getting things like imitating things that I'm doing. So it's kind of an interesting experience. So Rue Code is an extension for VS Code. And just like Copilot and all the others, it allows you to kind of define the task and it goes and run it for you. Now, one of the reasons I like Rue Code that it allows me to use from inside VS Code the VS Code API, LM API. So basically, because I'm working in Microsoft and the organization has access to all the models through GitHub, it allows me to still use all those. And so I get access to the models and I don't need to get licenses or something like that. But still I get all the benefit of the tool that I'll show in a second. And also, I don't break the compliance and regulation of my, of my organization because I'm still using the models that are accessible and allowed. And I'm guessing that other organizations have the same issues. I hear from friends working in other places, they cannot use this tool or another because the organization does not buy licenses or allow. So this kind of give the flexibility of choosing your provider. The second thing that I like about Rue Code is that it gives me a bunch of tools that I can incorporate in my work, whether it's reading and writing files, using an inside browser, going into the internet and fetching more information. And also, it can easily interact with the CLI, and I can easily say what are the approved commands that I wanted to use in the CLI and what are explicitly I don't want it to use. So I don't want it to even ask me if it can use this tool or not. And the industry and the community is just building more and more tools that just make the work of my agents super, super powerful. And so on top of that, I have this concept of, let's see if there's a laser pointer here. And I'm not sure if it's visible. But one of the other things that I can also kind of do, I have this concept of modes, which is now every tool has it. But with modes, I can basically give Rue like the high-level task that I wanted to do. And it has this mode of orchestrator that knows how to break it into a plan of different tasks that needs to be done, and then orchestrate it across the different modes. So I have a mode of an architect, I have a mode of a developer, and it just knows how to switch it for the specific task that it needs to do to get to the final point. So it runs in this type of a loop, and also delegating the different work into those different modes of execution. And again, there's a marketplace for all those type of modes. So if you need a specific mode like a documentation writer, you can just add it. And so the orchestrator will know how to activate each one for the different tasks that it needs to achieve. So it's super flexible and extensible. And so as a guiding rule, over time, what I discovered that in order to make the agent work well for me, I need to make sure it is limited to the thing that I wanted to do or not. And that's what's basically kind of gave birth to this concept of instructions that we have today. So my repos started to have this structure when I have this folder of .ru. This is where you put all those settings for the tool. And other tools have a similar concept like .cloud or .github. And so I have a rules folder with a markdown file for different aspects of rules that I want to have. So over time, I'm just extending it. So I have a rule file for all the coding standards, conventions, best practices, like what is the naming that needs to be used. Like I had to explicitly say that I do not allow it to do magic strings, right? At the beginning, when I just started, he started to put all those magic strings, and I always wanted to use const and enums and stuff like that. So I just put it inside the instruction file, and from that moment on, it made sure that it's working under the guidelines that I give it. So the same things I'm doing for the architecture of the project, or if I'm having some work practices of how it should always run tests, it should always run in a specific way, specific tools, I just put it inside the dedicated file in my instructions. And this is evolving. So every time that I'm discovering something that is not doing correctly, I just go and extend the instructions and make sure that it's not going to be repeated. Okay, so this kind of gave me a lot of power. I started to use the tools and, getting more tasks completed, more PRs are written. And at some point, I kind of said, it takes time for this to finish. I mean, I'm giving it a task, I'm giving it some objective, and it starts working, and it's in its loop, and I'm just sitting there and just staring at the screen. So why can't I start doing something else, right? I want to work while it's doing the work that it's doing. I want to work on something else. And now on the same repo, I want to like maybe go and fix another bug. I want to add another feature and stuff like that. And so I started to search for ways where I can really parallel the work and start doing it simultaneously. And at that point, I kind of got introduced to a very, very powerful feature that exists inside Git called Git work trees. How many of you have heard of work trees? Okay, so some of you heard of it. So, well, imagine that even without AI, you're working on something and you're in the zone, everything working great, and somebody comes to you and say, there's a very, very serious bug, we have to fix it right now. So you need to switch to another branch, but like all the context, everything you worked on now, you need to kind of, commit it, put it on the side, and move to something else. And while you're working on the bug, suddenly you see something and you say, oh, I need to refactor that. It's like, it's bugging me, I want to do it. And so you cannot like easily just go and do multiple changes that are unrelated on the same repo. The way people started to kind of accommodate that is they created another clone of the repo. But that's really, really hard to manage, having multiple repos, each of its own kind of dedicated assignment, but you start to manage that by yourself. Now, beside that, some repos are quite big, and the clone itself can take a while. So it's also gonna waste resources and like your time. Now, work trees are working in this concept where instead of taking the entire Git database and have it in a separate folder for each of the clones like before, all the work trees are going to share the same Git database, like you see here, right? So inside the main repo folder, I have the Git folder, and now instead of duplicating all the files and duplicating all the database and like the Git history and all those things, it can share it in a way that is really, really lean. And so when I'm creating another work tree, basically I'm creating this work tree for a specific branch, it's creating it instantly. And also because it's so easy to do, and like Git itself knows the concept of the work tree and the relationship, it's also really, really easy to manage and just delete it when you're done with that. And so using work trees, I could easily create multiple branches and work trees for different task assignment bugs. And now I could just run an instance of my agent. In that case, I'm running VS Code for each one. And for each of those instances of VS Code, I'm just doing something else, like I'm giving the tasks. And suddenly, the work I'm doing became of just alt tab between those windows, and each time just seeing if it's progressing in the direction I want. And if not, I'm stopping it and just give it instruction to do something else. But now I can really start to parallelize this work. And also, like one of the practices that became is right before I go to sleep, I just span a few of those windows, a few of those work trees, and giving each one like a major feature that I wanted to design and I wanted to start iterating on. And when I wake up in the morning, I just see the results and see if I got what I wanted. So it like, I felt like even when I sleep, I don't waste time. So work trees is something that is really powerful, and it's really easy to use. It existed for a long time, even before AI. It's just something that we never really thought about until AI really came and just took it to the extreme. So inside VS Code, if you go into your repository, the source control window, you can just add the repositories view, and now you could see all the work trees that you have. And if you want to add a new work tree, you basically just need to click on the three dots, and you have this menu item for work trees, which you just need to say, I want to create a work tree. Giving the work tree the name, giving the work tree the branch you want, or creating a new branch, and that's it. From that moment on, you see all the work trees, you can delete it, you can add, it's becoming really, really part of your process. And then I said, okay, why do I need to do the work, right? I have an agent, right? So one of the nice things I have in Root code is this concept of slash commands. So whenever you have a repetitive task that you are doing or repetitive prompt that you keep entering, you can just put it into a slash command. So I created this slash command of create a work tree. And so I just defined in this prompt that whenever I say work tree, just go create the work tree for me. And I want to use the structure for the branch the work tree is associated with this convention of the name. And also, because I'm using the VS Code Insider, I say, once you created the work tree, just open a new instance of VS Code Insider for this new branch that you created. And so now it becomes really easy. All I need to do is just do the slash inside the prompt window, selecting slash worktree, and then I write like, okay, I want a worktree for this new feature that yada, 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 do a lot of things. And like the agent itself is also the one that finds a suitable name, because naming is like the hardest job for an engineer. So it finds the name, it creates the branch, it creates the worktree, it open the VS Code for me, and I can now start working when this window pops up, right? So like I can start, as I'm thinking about things, I can just start typing, okay, work tree this, work tree that. I have all those windows popping, and now for each one, I can just start typing the instruction. And so the thing is that in VS Code, it can take a while until the entire, extensions are booting, everything is being starting up. And so I felt that it's another area I'm kind of wasting time. So I started to kind of play with the GitHub Copilot CLI, which is really cool. How many of you are using the CLI? Yeah, it's a very cool product, and it's advancing really, really fast. So a part of just creating the work tree, I said to Ru, okay, once you create the work tree, just use the Copilot CLI using the command of Copilot minus P, where you give the instruction. And basically, I want you to start thinking about this feature or bug or whatever. So as the window is opening, it's already starting to kind of think about the process and generating like the spec file that I want. So once the new window with true is activating and until it's finished, I can really start going and like keep going on the work without waiting for all these things to happen. So I can move really, really fast with those connection between tools. And this is just an example, right? You can see that it's open the code insider in this like folder that it created. And then it just gave the instruction for Copilot, and Copilot is running in the background and just doing the initial work for me. Okay, I just want to add that, again, as I'm writing this presentation, new stuff keeping it up. And so Copilot added this feature of a work tree. It seems like they heard my thoughts. And so they added this way of you to create these background agents. So now in Copilot itself, you can actually say, okay, I want to do this task and just do it for me in another work tree. So it's not perfect. One of the things that it's not perfect is that the name that you get for the work tree is work tree, I don't know, 1, 2, 3. It's not something, readable enough, but it's a step in the right direction. Okay, so now agents start working. They are doing the code implementation. They're writing documents, doing the spec, even analyzing like issues when I give them. That's all good. But at some point, I kind of felt that it's not enough because when they done doing something, I was the one that actually did like the final testing. I needed like to run the application, go into the UI, see that actually things look the way they need to look, and I'm getting the look and feel that I expect. And so I try to find a way to make it better. And also, sometimes I needed this tool to go and interact with other systems that are only available via browser or something like that. So I looked for the way to give my agent some eyes so it can really see what it's doing. And so one of the great additions that we have now is the Playwright MCP. How many of you are using the Playwright MCP? So that's a really cool thing. So Playwright is by intention was used for doing like this type of testing, right? UI testing, automation, and all that. But since Playwright knows how to interact with the browser and with the DOM and seeing like all the aspects of the website or the web application, we can actually use it as part of our agent using the Playwright MCP. And so most of the tools, the structure is really, really similar. You provide in your list of MCP servers like the name of your MCP, in this case, like Playwright, and specify how you want to run it. And the Playwright MCP is available through NPX. Now, one of the things you can specify is the type of browser you want to use. So we are using MS Edge inside Microsoft. And one of the things that sometimes I need this tool to do is to go into different systems or documentation that are not available publicly. So I wanted to make sure that the agent itself has access to the same things that I have. So first, I could have said, let's use the MS Edge. Second is that the Playwright MCP comes with an extension you can install in the browser, whether it's Chrome or Edge itself. And what this allows you to do is basically allow the tool to connect to a specific tab. So in the case where I needed to log in into a specific system, and I wanted to make sure that the tool is using in the context of where I'm actually done the work and put it in the right place and position that it needs to look at, I could do that. And so my configuration for the Playwright is that I wanted to use Edge, I wanted to use the extension. And so now when I'm giving the agent a task, for example, like here, use the Playwright MCP to see the colors in the open tab in my browser. So the agent knows that the MCP for Playwright exists in the list of MCPs. Suddenly I get this browser popping up and it asks me, okay, in which of the tabs you want me to look into? So I can just say, okay, go to this tab, connect to this, and it will go and see the view as I've seen it and can now interact with it. Now, because it has access to the full capabilities of the browser, it can go and see the console logs, it can go and play with the DOM, it can do a lot of interesting stuff. So the automation of visible things and the analysis of those presentation things becomes like super, super easy. And okay, so it got eyes, it can do a lot of work, they can work in parallel. And one of the things, again, I'm trying not to waste time, was that every once in a while, like I drive home, it's a drive that can take 1 hour, and I gave some task to my agent. And when I got home, I saw that it's pending and ready to my answer for something, right? And I said, if I only knew that it's gonna ask that, I could have answered beforehand and just let it run while I'm driving home. And so there are all kinds of ways today to do speech to text, right? You can use different tools in order to take the voice and just create the text. But I couldn't find something that actually do the opposite. So if my agent is waiting for my answer, or even when it's finished the work and trying to see if the result is what I expected to work, continue to something else, there wasn't anything that really gave that to me. So what I tried to do is find a way where I can really talk with my agent. And so while I'm driving, it's like an intern that I gave it a task, and I want to make sure that if my agent, if this intern is waiting for something, is stuck on something, it could give me a call and I could answer. And so the first thing was, how can I really use voice commands in order to execute it? And so there are various ways to do that. You actually have something built in inside Windows. I'm not sure how many of you know, but if you do the Windows key H, it's inside Windows. You have the accessibility thing that just record your voice, turn it into text. it's also quite good because if you say enter, it just knows how to finish the recording and just do enter on the screen. So that's really nice. Now, if you're working specifically in VS Code, you have an extension in VS Code called VS Code Speech, where you can now interact with VS Code via speech, which is also quite nice. But again, this only allowed me to give instruction, but not getting the feedback from my agent. And so that is when I decided to write my MCP server that allows to do this this specific functionality. So my MCP knows that first, when the agent finished the work, it will just summarize what it's done and voice it over. So I can hear what it's doing, and then it's waiting for my approval. And second, if the tool itself has a question, is waiting for my interaction for something, then again, I get this audio where I can hear what's going on, and then I can say, what is my answer for that? So let's see if we have the volume, and I can show you a demo of that. I don't know if you hear. Let's see. Yeah, I'm not sure if you can hear from the audio. Do you hear something? Okay, so basically.
What do you need help with today?
Do you hear anything? Okay. So I'm saying creating a C# project of something, and then you can see that suddenly this being added into the screen.
Create a C# project for Hello World. Is this correct? Say yes or no.
So it's waiting for my acknowledgement whether it's what I expected it to do. I'm saying yes, and then it run the rest of the instruction. It takes some while until it finished the work, and then it will respond back by saying what it did, and waiting again for my approval, because sometimes it's not doing the correct thing, and I need to give it further instruction. And basically, when I have this type of tool, I can run really this work while I'm driving and start interacting with those agents to make sure they are still doing the work while I'm driving home and I'm not wasting the time.
Application, 2 files. Program.cs containing Hello World code namespace and Hello World.csproj targeting .NET 8.0. The project.
And so that gave me another level of interaction. And I think that as we go along, it's really going to be like working with those teammates, interns working on your code. You need to instruct them. Each time you're kind of evolving the way they work with the code based on the convention, the guidelines, the experience that you have. And now you can really interact them by voice. And at some point, I wouldn't be surprised if they're going to really start calling into my phone, so I can really talk with them when they need me.
Has been successfully compiled.
Okay, so what I showed until now is that now I can run multiple agents on my system. Each of them is doing work. They interact with me. I interact with them. I give them eyes so they can look at things. They can run their own browser instances to make sure the work they're doing looks the way I want it to work. But again, it's all running on my machine, right? And that's kind of, it's counterproductive for me because while they work, I want to keep doing other stuff, right? And there's a limit to how much my machine can really carry. And so I looked for something that allowed me to run them in the background. And so one of the things we are using in my team is the Microsoft DevBox. Do you know Microsoft DevBox? Cool. So like the DevBox allow you to span machines in the cloud with a specific configuration that can be with the tools you use, with like the configuration of the team and stuff like that. And so I created my DevBox where I can run the same workflow of having multiple VS Code instances running, each in its own dedicated task. And one of the nice things that we have is this extension that exists really for a long, long time called the LiveShare. How many of you have used LiveShare and know LiveShare? So I'm going to show you what LiveShare give you, and you not need necessarily to use it just for AI, is really easily, if you go into your, whether it's VS Code or Visual Studio, it doesn't really matter, you have a little icon after you install the extension called the LiveShare, right? That you see here. So with LiveShare, I can now click on that. And basically what it does, it's creating like a secure channel, a secure tunnel into your VS Code. And it's asking whether I want to allow this read-only or read-write access to my shell, to my stuff, and all of that. And so after it finished to do the sharing, I can just, let's say I also want to invite others, and I'm getting a copy of a link that I can now share over Teams, or in this case, I just copy and I have it in my clipboard. So now I can, just let me copy it. Okay, so I copied the link. Hopefully, it copied it now. And so, not good enough. So let's do it from inside into Teams or something. Yeah, these are the demo gods playing tricks on me. Okay, it copied something. Okay, so I'm running this link, so you can either now get access to this session through the browser, like you see here, or I can open inside my VS Code instance running locally on my machine. And basically now my VS Code is going to display exactly what's going on in the VS Code on the remote machine. And not only that, I can also kind of interact and interfere what's going on inside. So you can see, for example, that I can like see here that what's going on the agent side, right? This line is the one that is in yellow, is the one that is being marked on the machine, the remote machine. And if I'll go now and like use the terminal, so the terminal itself is also the terminal that it's running on the remote machine. So I can also like run commands here, but actually they run on the remote machine. So this is really like the initial proposition of that was that I can communicate with my friend running something and helping him debug it. But now my friend is actually an agent, right? So I can see what the agent is doing. I can go and like change the stuff or fix stuff or just see what's going on, even though it's not running locally on my machine. It's much leaner. It takes less resources. So this is like a pro tip if you're using this concept. It makes it really interesting experience to start working with all those agents running remotely. And I'll also give a good word for Copilot, because now Copilot also allow you to do this concept of running in the background. Again, it's not like perfect. And like one of the reasons that I'm still using my approach with all those VS Code instances running is that I still want the control on the tools. I still want it to run under my identity, running the tools that I provided, working with my instruction. And I haven't felt that Copilot is in the same position, but it's getting there. So maybe in a few months, all this presentation will be no longer necessary, but let's see about that. Cool. So my agent can work on a project, on a task. I also allow it to run in parallel remotely. So I'm really, utilizing all the resources that I have. And one of the things you can start hitting is that mostly the applications I'm working on, they are not like an island of its own. Sometimes they have dependencies. They need to span like a database. They need to span like a queue. They need to run other services running all together. And when you run those multiple agents simultaneously, you start to hit those limits where they can interfere each other, right? They need to run against database. So how do I make sure each one has its own database that they run and they test and they do stuff? So basically, the thing is, how can I allow those agents to run for me on a distributed system? And so this is where Aspire becomes really, really handy. And so Aspire, if you are not aware of, is an opinionated cloud-ready stack for building your distributed application. And though it's something that came from .NET, it's a polyglot project. Even if you're not working in .NET, even if your entire set of application is in Python and Node or whatever, Aspire still allows you to do this type of orchestration really, really easily. And so Aspire is kind of separated into three parts. So the first part is really the composition and orchestration. It's kind of the language that allows you to define all those components that are part of your system and how they interact and depends on one another. And the second is really for the application side itself, those integration or components where you can kind of get out of the box all the cross-cutting concerns for your applications, such as resiliency and telemetry, observability, and all that. And the third area is the utilities that Aspire give us. For example, we will see in a second, it's the dashboard that allow you to see the state of your system and the connection between the different elements, seeing the logs, seeing the metrics, and all that. So there are a bunch of things that come under this Aspire engine. And more of anything, this now allows me to take a full system and run it in a way that my agent can really get the entire system up, getting access to all the components and the logs, and really, really be like independent in the work it's doing. And so just kind of a really, really, really short introduction of how it looks in Aspire. So the main area in Aspire is the app host. It's the place where you define your application. So it all starts by creating this distributed application builder where you basically gonna add all the parts that kind of structure your application. So in this case, I'm adding a Redis and I give it the name cache. And I'm adding a database called Postgres, called the database DB. And inside Postgres, I have a database, a logical database called NoteTakerDB. And now I'm also adding RabbitMQ. So I have a different pieces. Currently, they're really, really disconnected. And now I'm saying that my system is built from a project that I have in my solution. This is the backend project. And this project has a reference for each of the other dependencies we saw before, for the cache, for the DB, for the messaging queue, and all that. Now, what happened now is that Aspire knows how to connect those things, and it basically injects environment variables for all those pieces. So when my application starts, now it has access to all those things, and the way it is written, I can also make sure that things are kind of spinning up in the right order, and things are waiting for one another before everything is available for work. The same thing I can do with an application which is not a .NET application at all. So in this case, I'm adding an AI application that I have from Python, and I just specify where it is located in my repo. And this application also has dependency. It's referencing the database and the messaging, and I'm also specifying that it has some HTTP endpoints that I want to have access to. And the same I can do with another type of application. I have a front-end application written in React, and this is a JavaScript app. And this app has like a script that needs to run when it's starting, so I'm just specifying it here. So the nice thing is that first, any member that comes to my team can now take this application, F5, and everything just works and connected without the person needs to go and like reading docs and doing configuration stuff. Everything is just embedded inside this app host. But now, this new team member is not a person, right? It's an agent. So now my agent can really go and run the entire set of the application, the systems, really, really easily. And so when I'm running the application, I get a view. This is the dashboard where I can see all the components, like all the pieces, the cache, the database, like what's the status, is it healthy or not? What is the URL it's accessible through, all those stuff. And I can see the environment variables, and I can see the logs, and I can see everything. And so I have Playwright MCP. So now when I'm running the application, I can basically say to my agent, you know what? The dashboard is running in this URL, and there's something not working correctly. So use the Playwright MCP, go and fetch the endpoint of this specific component, and investigate what's wrong with that. And so the agent can really go, it opens through the browser, the dashboard, it can start clicking on stuff and doing all that. So that works, but we can do better than that. So at 2 versions prior to the current one in Aspire, they also added an MCP. And so now I can add the Aspire MCP to my agent, and through this MCP, the agent itself can now go and get all the resources, it can get the logs, it can get the metrics, it can get everything. So now, for example, my application had a bug. You see, it gave me this error message. So once I connected the MCP for the Aspire, I just told it, you know what, go look at the logs of the backend and use the Aspire MCP and just tell me why it's failing. And so it started to investigate. I'm not sure if you can see it like too well on this projector, but it started by activating the list resources tool. It got all the list of resources, and then it used the list console log, so it investigated the logs, and then it went and analyzed the code itself based on the error it saw in the logs. And finally, it says, okay, I'm seeing why we got this exception, because I know that in your code you have this and this and that. So that's kind of make it really nice, because now I no longer need to kind of connect the things like the dashboard URL and all that. It can do it for me. So that works really, really well for the AI to investigate issues or just iteratively work on something and see how it's progressing. The thing is that like by default, Aspire uses the same ports and like the same configuration and everything. So if I'm running parallel agents, each in its own work tree, and all of them are running, suddenly they are going to start to like connecting to the wrong dashboard or to the wrong resources. So I needed a way to do this isolation between them. So after some thinking, I created this type of scripts. So basically, in my repo, I have a script folder, and each of like the function you need to do with Aspire, like starting the Aspire or closing it or seeing the state, I did it in a way that each of these scripts actually allocate a random port for each activation. So when I tell the agent to start at app host, it will run the start app host script, which will allocate a port for the specific instance that it's running and store it inside a local configuration. And so now each of my agents really run in an isolated environment, different ports, different containers, different configurations. And that kind of worked really, really well. I added into my rules, remember when we started that I have my rules folder for rule, so I just added this as a rules that whenever you need to run the application in the app host, make sure you run these script files. So now that we have agent skills, I also kind of converted it into agent skills, so it's even much leaner than just the full rules document. The issue was that MCP works a bit differently, because when you add an MCP, the MCP is kind of static configuration that you have for agent. And so when I added my Aspire dashboard, I couldn't really dynamically make it connect to the remote server for each of my instances. Because you have to put the URL, which was with a static port and also the way Aspire works is that you need to put a token for security reasons. And the token is also going to change between the different instances. So I had an issue because I wanted each of my agents in each of the work trees to really be isolated all the way to the MCP server. So the fundamental theorem in software engineering said that every problem can be solved by another level of indirection, except for the problem of too many level of indirections. So I created an indirection for the MCP. And basically, I just implemented a new MCP server, which is the Aspire MCP proxy, that has a static configuration that is locally, but it knows how to read the configuration of the currently running instance. And that way, whenever my agent talks with the Aspire MCP proxy, it talks with the same local instance, but this will delegate the work to the real MCP for my running application. And that way, I can really now have all those agents running, each one in an isolated environment, interacting with the MCP to see the status of the application, analyzing issues, solving problems, and continue. Okay, so now my agent is really, really independent. So far, works really, really well. And the other side of Aspire is that basically, if I already capture the entire structure of my application and I can run it, I can now run tests that are distributed tests really, really easily. So I don't need my agent necessarily to figure out how to test each time. And I also want to make sure that my agent doesn't do regression. And the only good way for me to make sure that my agent is performing well and not breaking stuff is to have tests. And in something that is distributed, I need to have tests that really run sometimes end to end. And so Aspire give me this tool to make those type of tests. So with Aspire, I can now take the app host that I configured earlier, and I say, okay, let's run it as a testing application. And basically, I'm just running it inside my unit test. And once it's running and I get the instance of the application, I can go and ask for the resources, endpoints, or the different resources that I have. And with that, I can start doing things with Playwright that really run against, let's say, the front end or the back end, and really see that things are working correctly. If a message is being queued into the queue and another resource needs to retrieve it and do something, I can check this end-to-end still in an isolated environment. So now my agent can also add tests that test what it's doing in an end-to-end in a really, really simple way. Cool. So I have all those agents. Each of them did a work. And now, I need to complete it. I want to have a PR, and I want to make sure that it's working. So my work transformed from, doing all the coding and everything to really supervising my agents and just reviewing the PRs that they are doing to make sure it's really doing what I expected it to do. And the only thing now is to really complete the work. So what I did is that I added another / command that's called complete work. And basically what I'm saying is that whenever I run this command, I wanted to commit the changes. I wanted to push the branch. I wanted also to create a PR with a meaningful description and like a meaningful title. And because the way those tools work when they need to create all those descriptions, they create a file, I explicitly said that I want the file name to be PR_description MD. And why did I do that? Let's see if you have an idea. Why not allow it to do any name? So the thing was, yeah. So the thing is that if it was any name, once it commit, it will also commit the PR description along with it, right? And I didn't want it to commit that, right? So I had to find a way to make sure that the file it's creating will be ignored. So once I gave it a single name that it's using, I could just easily say in my git ignore this file. So even though it's creating it and each of my isolated environments is creating this description, I make sure that this file that is just a utility file doesn't get committed into the branch mistakenly. And so when I run it, like in this case, right, we can see that it just really create a PR. In this case, it's for GitHub, so it's creating a PR in GitHub. It like gave it a meaningful title based on the work he did, and took all the description from this file, and I'm getting eventually a PR ready for me with a description that I can go as a human read, see all the changes it did, and give it now comments. And if something is not correct, I can put a comment and I'll just tell the agent, go read the comment from my PR and fix based on that, right? So I don't necessarily need to go and do it manually, right? I do it like any other team member, just putting comments on the PR itself and then run it from my specific isolated environment that I have, so it can continue and fix all those things. Okay, so that's basically the process that I kind of adopted, and it's changing like every day. And once I do that, really, I feel like I have like an army of engineers running for me, right? I can go run in parallel multiple tasks, go make sure they are doing the work, and I'm much more, I'm trusting the code much better now because I know each of them can have an environment where I can really test it and run it and do the full cycle. And I feel like this is really a boost in the productivity that I got over the last couple of months. And that's it. So any questions?